All right, so good evening everyone, hope you can hear me, and thank you for joining this presentation. I must admit it's a bit of a challenge because being the last presenter or one of the last presenters in the room before dinner is a little bit like being a model validator. Everyone knows you're necessary, but nobody really wants to take it too long, so I'll try to be both useful and brief. So this is actually a good starting point because model risk management actually has the same kind of challenges. It has to be rigorous enough to prevent and to protect the organizations, but on the other hand, it has to be also efficient enough not to slow down basically the whole process. And so what I want to start is with a question, which is, could you prove why a model was trusted to make the decision that it actually made? So imagine that maybe a customer or a regulator or your executives may ask you this question to understand what's happening within the model, why is that model making a particular decision? Well, could you answer the question and prove the answer in a few minutes, or would you have to actually make an investigation? So where is the model originating from? Who is owning that particular model? Is the documentation comprehensive? And is it actually comprehensive enough to justify the use of the model for the use case for which it was designed to be used? Have you performed any policy assessment? Is this model in compliance with the policy? And obviously model validation, as well as are there any issues with the particular model? So as you can see, being able to collect and to answer all of these questions means you need to have a good grasp on all the various aspects of the life cycle of the model. So what we'll try to do today is to see what happens when this governance fails, as well as how do we actually make things a little bit better using also GenAI technology and in general the model risk management solution for SAS. So first of all, when the governance kind of fails, essentially the risk is not technical anymore. It becomes essentially much bigger. It becomes a financial risk, it becomes operational risk, reputational risk, it becomes human risk. And so here are just some examples from recent history. In 2021, Citibank was fined 3.1 billion by the FinCEN for their AML practices, where essentially they were running their models in production, but across a large number of transactions. However, they were not actually being monitored, and that obviously caused a bit of a concern from a governance perspective, which ultimately led to an investigation and big fines. So this is a big example of what could go wrong from a financial perspective. There's a case in the Netherlands where also in 2021 the Dutch government actually was forced to resign as a result of this scandal, because basically AI models were put in production to make decisions about benefits from child benefits, and families were wrongly accused of trying to defraud these child benefits. However, it was actually a mistake, an hallucination of the model, and obviously the families were actually asked to pay back large sum of money, which caused a lot of troubles and a lot of issues within the government, and ultimately again the government retired. So this was actually a human cost of not having the right governance. And then the third one is a case of strategic cost, where a few years ago, post the pandemic, Zillow put in place a model for basically predicting the house prices. Zillow is, for those of you who may not know, is one of the biggest company that basically you can use to, if you need to buy and sell your house. You can list your house and you can sell it. They have realtors. And what happened is that they used this model, which essentially was trained on pre-COVID, pre-pandemic data, and it was not trained on the volatility that happened after the pandemic. And so it ended up being overestimating the prices of houses. And the team that was responsible for using this model was also asked not to perform model adjustments on top. And so as a result of that, Zillow used this model for over 7,000 transactions, and they ended up spending almost 100 million more than they should have because of the price inflation. This was actually a huge loss for Zillow, which also ended up into 25% of the workforce was actually laid off as a result of basically of these losses of the company. So consequences are usually go beyond just the pure technical risk associated with risk management. And essentially the pattern behind all of this is that when the governance, it was not just the model that failed itself. Obviously models can be good, can be bad, they have a tolerance level, but when the governance around these models fails, that's where the real problems start to surface. And this usually boils down to having weak evidence, not having enough documentation, not knowing when a particular model is being used, and is it in compliance with the policies for which it was supposed to be used. But two particular issues typically happen in the governance. One is about the delays with which issues are being surfaced and then also being addressed. Sometimes it takes a long time to even recognize that there's an issue, and even once you recognize the issue is there, it takes even longer for the policies to take effect and to fix it. And another aspect is that this is the unfortunate reality of model risk management, is that it is a fairly manual process, because you have to deal with multiple models, having to deal with all the documentation across multiple models. So teams in the model risk management department are typically fairly small, and so they have to deal with a large number of models. Imagine when you have hundreds, if not sometimes even thousands of models to deal with. This is what typically happens in many organizations that we work on. Basically, you see model repositories which are scattered all over the place. You have model repositories in Python, on SharePoint, on Excel files, sometimes on the cloud, maybe using Google, maybe using Azure. The reality is that all of these repositories are not obviously connected, and it is very hard to find out what is the relationship between the models, what is the contagion that could actually happen within different models if the output of one model is becoming the input of the next model, or multiple of those models downstreams. What happens when the performance of that input model starts to degrade? Well, how many models are going to be affected? If you don't have a good relationship and understand what is the connection between all of these models, obviously you cannot answer the kind of questions to see what could be the downstream impact. So SAS model risk management is essentially kind of a nervous system of the model risk management problem, where we are essentially combining all of these different aspects from it tracks the entire life cycle of the model, from inception all the way down to in production, finally into retirement. Now, to make this useful, you can't just be at the center and ask everyone to load the model into your system. So you have to be able to go and grab the models wherever they live. And so we actually define API connectors that let you load models from Excel files, from Azure, from Google, and also obviously from a SAS Model Manager, which is our own SAS model repository. So it's obviously integrated within the SAS technology. But we also created a number of copilots or GenAI technologies that basically help us with some of the governance aspects, which are the most tedious aspect of the model. And one that I'm going to show you today is about the policy assessment. So before we get into that, I'll just pause a second, because I want to show you a little bit about how do we import the models, and then we'll talk about how the policy assessment helps us into the model risk management practice. So to let you import models from different systems, we have created, again, these API connectors, and you have the ability to predefine mapping templates, so that obviously if you're importing a model from one system, you have to map what does this particular field on that system mean in terms of a corresponding field that we might have in our own system. So having that kind of mapping, you can quickly define it once and then reuse it every single time when you want to import multiple systems, multiple models. Now, going back to the policy assessment, this is where really the slowest aspect of model risk management really is about, because what happens is models typically are assessed against policies, and they need to be complying with those particular policies. It could be this could be internal policies, or they could be external policies, regulatory policies. And the reality is that to assess the compliance, you have to go and read all of the documentation, look at all the metadata, all the model validation information about the particular model, collect all this information, and then answer a questionnaire typically to say, is my model in compliance with this particular policy? Now, this is obviously a manual process, is labor intensive, and if you multiply this by the number of models that you may actually have, this can easily become a problem, because either you cannot do it properly, or you do it very quickly because you got to move on to the next process, and that's where governance starts to crack. So what we have in the SAS model risk management solution is a Copilot that actually helps you with this process, because it knows all of the metadata around your model. It can scan the documentation that are attached to your model, and it can actually extract this information and check it against your policies to create automatically an assessment that answers the questions for you. Now, this has been actually optimized for accuracy rather than hallucination, because the reason is that sometimes LLM want to answer a question even when the fact is not there. So they always want to please, they always want to try to find an answer for every single question. What we actually train our system is to only give answers when they are grounded from reality, based on fact that is available in the documents, rather than trying to give an answer for everything. So the system is actually telling you how many questions it's able to answer versus the ones that it's not able to answer. And one of the most important pieces is also about the provenance aspect of the models, because not only you have to be able to answer a question, you also have to show where does the information come from. So which document did I use to answer that particular question? So with that, I'll move into the demo section of this. So before we get into kind of the nitty-gritty of the Copilot, I'll give a kind of quick overview of what the SAS Model Risk Management solution is about. So on this main page, what we're seeing essentially is a kind of a quick overview of the various models that are being tracked by the system. So you have all the use cases, the models, the evaluations, and any findings or issues that have been associated with those models. And each issue is classified based on the type and the severity of such issues. Now, before a model can actually enter the life cycle of model risk management, we have to do something that's called model candidate assessment. We have to assess whether that model is going to be following the process, or it's just a type of a tool or an asset that doesn't need to go through the MRM governance. So usually you fill in a kind of an assessment form, and based on that, you decide whether the model is going to be actually treated as a model within the system, or it's just a simple asset that doesn't need to go through the full governance. Now, once you decide that the model is going to be registered into the system, well, you have multiple ways in which you can register these models. So models can have, obviously, policies, but if I want to register a model within the system, I can do it either manually through the UI. Obviously, I can click on the system and start adding information, or I can data load this information from Excel. Or finally, I can also use data connectors that I was talking about earlier. Here we have examples with a model manager and Azure AI Foundry, where if I want to import a model, I will first obviously select one of the models that are available in that repository. I will then I have to kind of map what are the input variables with the variables that are within the MRM system. But of course, this could be, I don't want to necessarily do this every single time, so you have the ability to save this one as a template. You can define the mapping once and then reuse it multiple times. So if you need to import multiple models, then this becomes much easier to do over time. Obviously, once I've done this, I can just go ahead and kind of click on import and then bring in my model. So going back to the model, now the model object is kind of the most important aspect of this solution. So what you're seeing here is what is the status of the model in production, what is the performance rating, the overall rating, the risk rating, what is the scope. This one shows us that the model is using AI. And if you go into the development section, you can see what languages have been used. And in this particular case, for example, the model is a machine learning model which uses supervised learning. So you have all these attributes that basically that you can keep track of. Obviously, a model has policy assessments. So there are policies that are attached to the model, so which means that the model needs to comply with those particular policies. And being that this was an AI model, it needs to comply with the EU AI Act. We're looking also at the risk assessment, so you can define risk assessment, materiality, validation assessment. There's a lot of, and the risk rating overall of the model. So there's a lot of different KPIs around these models. And we also have a documentation section where we can attach essentially any kind of documents that are being created throughout the life cycle of the model, from all the way from inception to until the model goes into production. Here we're showing the actual workflow. As I was saying, MRM actually tracks the entire life cycle of the model, all the way from the moment which you decide you're going to use MRM to track the model, all the way to development, validation, production, and then eventually it's going to be retired. Finally, on the policy side, here you see that this particular model is connected to the EU AI Act policy because it's governed by that particular policy. And what you're seeing here is an assessment this is the type of assessment that for every single model that is governed by that policy, you would have to go and basically answer this question. And again, if you have to do this every single time for all the models, it can be quite an extensive part of the work. And that is where actually the Copilot comes into play. So what we're going to do now is on the left side, we're opening the Copilot, and the Copilot already has preloaded, recognized the model that we're already working with, so it does automatically load the context. And all we have to say is basically assess this model against its own policy. We don't even have to say which policy, because in this particular case, as you can see, the policy is already defined within the model. I don't have to specify anything else. And the system basically, what it does, it pulls all the metadata information around the model, all the validation information that might be relevant, as well obviously as the attached documentation that was within the system. And it's going to create, first of all, an assessment object, and also gives us a kind of summary to tell us how many questions did we answer, how many questions are still left unchecked, and they need to be answered. So when I click on it, we can see that 78% of the questions have actually been answered automatically by the assessment. Another important aspect is that for every single question that we are answering, you have a link to the regulation, or which portion of the regulation might be relevant to answer that particular question. So, for example, if we click on the first article, it brings us to the EuroLex Article 6, which is relevant for answering that particular question. So you have an actual full context, and the LLM is able to read that context to determine whether it's going to answer or not. And here you see the provenance, where we're actually showing you how do we actually give that answer. We didn't make it up. This information was available within the document itself. And you can also see the confidence score. The LLM is telling you how confident it is with the answer that it gave. And obviously you can see in red highlighted any question that has not been answered because simply the information wasn't available. And obviously you can then go ahead and either modify any of the answers or change them, or again, this one is the last piece, the last mile that typically a model validator would do. So going back to the model, this section here shows what we call the performance monitoring plan. Every model is has a performance monitoring plan with a number of KPIs that we're tracking from a validation perspective. For each KPI, we can define what are the thresholds that we should monitor against. And obviously, as we go through the life cycle of the model at recurrent phases, you perform a validation, which we're seeing right here. There are multiple evaluations, multiple reviews that have been performed. And for each review, basically statistical data can be attached to the model, which can then be analyzed to detect whether there is a drift in the performance of the model is stable, or maybe is deteriorating over time. We also have a section related to findings, any issues that we have with the model. And here, as you can see, there's a critical issue with a particular model. And long story short, I mean, the description is basically telling us that in this particular case, the model exceeded one of the thresholds that was defined for a particular performance monitoring. And so that could be a sign that the model needs to be potentially revalidated or calibrated in this particular case. And finally, on the main view of the models, this is what is the model card, where you get actually a summarized information of the model. You get some of the kind of the details, some of the main scoring information, like fairness, explainability of the model itself. And as you can see on the top, that critical issue that we just analyzed was also reported on the model card. So you don't have to actually go and fish for the information. It is actually already available within the UI itself through the model card. And sorry, So to end this presentation, basically the idea is model risk management typically has been primarily a control function, which is necessary, but typically it slows down the process quite a lot. So what we're trying to do is, through the usage of AI, is make the process more streamlined, still keep you in control because the user still needs to be in control, but remove the mundane aspects of the labor-intensive aspects basically of the process. So the idea is, what if the governance can actually become a competitive advantage rather than always slowing down the whole process? So this will enable us actually to scale with confidence that we can trust the model that we're using. So with that, thank you everyone for listening, and if you have any questions, I'm here. Otherwise, also you can come and visit us at the financial section right at the front. So feel free to come over if you have any questions, if you want to see more about the capabilities of model risk management.